Hello, wonderful people. I welcome you all to Physics with Umoru. Still on the topic, the images formed by a concave mirror. We are going to be looking at using the ray diagrams to represent the images formed by a concave mirror. Like I told you, that the type of image formed by a concave mirror depends on the distance of the object from the mirror. So we can't say that these are the properties of images formed by the concave mirror, but we'll be listing them out. We need to consider the distance from the mirror. All right, so this is the concave mirror. As we discussed earlier, this line is called the principal axis. This point here is the pole. If I will measure a particular distance here, let me label it F. I'll measure an equal distance here, the same from here to here. I will measure another one. Let me call it C. And I'll measure maybe another one, or maybe half of it. Okay, so this, we want to use this to represent the properties or to determine the properties of the images formed by a concave mirror. So we are going to be placing the object at different positions here. One, we are going to place the object here, which is like a position or a point that is beyond the center of curvature. Remember, this is the center of curvature. This is the principal focus, and this is the center of the mirror or the pole. Okay, so and this is the point that is away from the center of curvature. So when we place this object here, then we'll determine the image. We are going to use the ray diagram to get the image that is going to be formed, and we are going to list out the properties. Now, listen to the following. You are going to take note of the following. Number one is that when an object is standing in front of the mirror, I'm going to be using two rays from this object. One of the rays must be parallel to the principal axis, and the second ray must be diagonal. One of the rays must be parallel, and the second ray must be diagonal. So let's say an object is placed here. I'll have to draw a line that is parallel to this principal axis. And remember that any ray that is parallel to the principal axis, when reflecting or when returning back, it must pass through the principal focus. Now, the next one is the diagonal line or the diagonal ray. The diagonal ray is going to pass through the nearest point to this. Okay? So for now, it's going to pass through the nearest point to this. So, and what are the points? We have a point here. We have a point here. So one ray will be parallel, and the next one will be diagonal. I'm talking about the incident ray coming from this illuminated object. All right, so to draw, I'm going to draw a line from here to this is the incident ray, the parallel, and the parallel is going to pass through this. It's going to reflect through F. Okay, so this is the reflected ray, the first one. Then the next is going to be the diagonal ray. The diagonal ray will pass through the next point, which is the C. So this diagonal ray, when it passes through this C. Now let me tell you something about this point C. Any ray of light that passes through the center of curvature, the center of curvature is just like a neutral point. Any ray of light that passes through the center of curvature is going to bounce back through the center of curvature. Okay, I said any ray that is parallel will pass through F, but any ray that passes through the center of curvature is going to return back through the center of curvature. So take note of this. So this is the incident ray, and it passed through the center of curvature. So when it hits the mirror, it's going to reflect back through the center of curvature. So where the two reflected rays will meet, this is where the image will be formed. All right? So if you look at this, you notice this is the first reflected ray, and this is the second reflected ray, and these two met at this position. So from the point where the from the point where the two rays will meet, this is where the image will be formed. So from here, you just draw a line up to the axis. And if the image is formed under this line, just know that the image is inverted. And if the image is formed at the top of this line, like on the top of this principal axis, just know that the image is going to be upright. So since this image is formed under the line, the intersection occurred under this line, so the image is going to be inverted. So you put the arrow down. So what are the properties? When the object is placed beyond C, which is the center of curvature. When an object is placed behind or beyond C, what are the properties of this image that will be formed? Number one, is this image going to be real or virtual? The image is real because the image is not formed in the mirror, it is formed outside of the mirror. So look at the image here. So the image is real. So the image is real. Number two, the image, as you can see, the image is what? Inverted. So always remember this, that most real images are always inverted. Most, I said most. Most real images are always inverted, and most virtual images are always upright. So take note. So since it is real, as you can see also, it is formed under the line, so it is what? Inverted. Now, what can we say about the size? The size of this image form. When you compare this size with the size of the object, you notice that the object is bigger than the image. Therefore, what can we say? That the image is smaller, so which means the image is diminished. The image is diminished. And number four, what can we say about where the image is formed? The image is formed, you can see, is between the principal focus and the center of the curvature. So we can say that the image is formed between F and C, between the principal focus and the center of curvature. So these are the properties of images formed by a concave mirror when the object is placed beyond the center of curvature. The image is real, the image is inverted, the image is diminished and formed between the principal focus and the center of curvature. All right. So the next position we are going to be placing this object after beyond C is at C. We are going to place the object beyond C, at C, between C and F, at F, and between F and the mirror. So still on this, we have the principal focus here, we have the center of curvature. So we are going to be placing this object at the center of curvature. So this is the object at the center of curvature. So remember what I told you, that one of the rays must be parallel and the second ray must be diagonal. Now the parallel ray, if we are to draw, we can use this. This is the parallel ray. This parallel ray, when returning back, will pass through the principal focus. Okay? Now, the second ray is going to be diagonal. And the diagonal, you see, I told you, we always pass through the next point. And where is the next point we have here? The next point we have here is what? The principal focus. So this ray, incident ray now, will pass through the principal focus. So it's going to pass through the principal focus, the incident ray. When it hits the principal focus, now I want you to know this. There's what we call the reversibility of light. Reversibility of light is just the ability of light to pass or to reverse through the same path it came. Like, for example, you know that if you point torchlight this way, just parallel or in a way that is perpendicular to a wall, in this format, you notice that the ray is going to return through the same path to you. If you point the light diagonally, let me say this way, you notice that it's going to reflect in another direction, but if the same torch is taken to the other direction, it's going to return back the former way you used. So if a ray is parallel to the principal axis, this ray is going to return through F. What if the ray will pass through F? You notice that reversibility of light, the ray is going to return parallel. If a ray is parallel, it passes through F when coming back. What if the ray will pass through F? It's going to return parallel when coming back. So this is what we call the reversibility of light. So if this second ray will now pass through F, you notice that when coming back, it's going to return parallel. Now when we draw, we are going to get this image. And this image formed, as you can see, is going to be inverted. Why is it inverted? Because it is formed under the line. So what are the properties? Now, when the object is placed at center of curvature, number one, is the image real? The answer is yes. The image is real because it is formed outside of the mirror. Number two, it is inverted because it is formed under the line, so it is inverted. And like I told you, most real images are inverted. Number three, what can we say about the size? The size is going to be the same as the size of the object. So same as the size of the object. Now, what are we going to say about the position? Where is it formed? So the image is formed at the same center of curvature, formed at C, at center of curvature. So these are the properties. You see that when an object is placed at center of curvature, this concave mirror will start behaving like the plane mirror, because you know that the plane mirror will give an image that is the same size as the object. Okay, you give the same size, but not about the inversion. All right, so but just know that the image is real, the image is inverted, but the same size when the object is placed at center of curvature. All right, so the next position we are going to be placing this object will be between F and C. All right, so if the object is placed, if the object is placed between F, principal focus, and C, center of curvature, like I told you, number one, a ray will have to be parallel. And the other one will be diagonal. So the parallel ray, when it hits the mirror, must pass through F. Remember? So it's going to pass through F down. Okay, so this is the reflected ray and this is the incident ray. Now the second ray is going to be diagonal and we pass through the next point. So the next point is F. So when it hits the next point here, when it hits the next point here, which is the incident ray, is going to reflect parallel. Remember that if a ray is parallel, it will pass through F. Now, if a ray will pass through F, it's going to return parallel. So it's going to return parallel, and we are going to have the two reflected rays meeting here. So if I'm to extend this, remember that they met at this point here, which is under the line. So I will draw this line to represent the image. So it's going to be inverted. So what are the properties? Remember this object was placed between F and C. So when the object is placed between F, which is the principal focus, and C, number one, the image is real, as you can see, formed outside of the mirror. So the image is real. Number two, we can say that the image is inverted. Real and inverted. Always remember this. The image is inverted. Number three, what can we say about the size? You notice that the size of the image is bigger than the size of the object. So you can say that the image is magnified or enlarged. The image is enlarged. Okay. And number four, so we can just say the image is magnified or enlarged. And number four, where is the image formed? You notice that the image is formed beyond C. So the image is formed beyond C. Now, this will interest you to know something about the reversibility of light. If you can remember that when the object was placed beyond C, the image was formed between F and C. If you can remember the first case we looked at, when the object is placed beyond C, the image was formed between F and C. Now, the object is placed between F and C, the image is now formed beyond C. That is about the what? The principle of reversibility of light. Okay. So I want you to also notice this. You see that as the object is coming closer, the image is moving backward, far away. That's two. And the next thing I want you to observe is this. This object, as the object is coming closer, the size is increasing. At first, when the object is placed beyond C, the image was diminished. Now we moved it closer to C, okay? I can use these two markers to represent. This is the object and this is the image. Beyond C, you see that this was formed here. I moved it here, forward. This one moved backward. I moved it here. This one moved backward. So let's see what will happen here when the object is now placed at F. All right. So this is the principal focus and this is the center of curvature. When an object is placed at F, let me not make it that big. When an object is placed at F, F is the principal focus. Remember our rule that a line is going to be parallel and the second line is going to be diagonal, but there will be a twist here. So let's watch first. Our line, the first line is going to be parallel. Now, this parallel, remember, when reflecting, will have to pass through F. So this is the first reflected ray. Now, the second ray is going to be diagonal. But you notice between here, this is just the mirror itself. So we don't have any other point here. Something will happen. This ray will start, this diagonal will start moving upward. That is, it's going to strike the edge of the mirror. But any ray that hits the edge of the mirror is returning back through C. So when drawing this, you have to adjust your line in such a way that this line will be able to return back through C. Okay? So this will be your diagonal ray, the incident ray that is going to be diagonal. And when you hit the edge of this mirror, this ray is going to return back through what? Through C. So this is the reflected ray, and this is the incident ray. So when it hits the mirror, it's going to return back through C. And you notice that this reflected ray, if I will extend it downward, 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 for the image to be formed, it means that what? The two reflected rays must coincide. The two reflected rays must intersect. But you notice that if I will continue this, we have just a parallel line. Also, if I will continue this up here, I will also have a parallel line. They are not going to meet. Okay? Parallel up, parallel down. So, and in mathematics, you know that two parallel lines will meet at infinity. So let's say you continue drawing this, drawing this, drawing this, drawing this. Before you move from here to the Mars, the lines will definitely meet. Okay, so that's what meeting at infinity means. So it will meet at infinite. All right? So, which means that if at the end, these two lines will meet, that is where the image will be formed. Okay, so we can now say that the image is formed at the what? Infinity. The image here, because these two lines will meet at infinity, therefore the image is going to be formed at infinity. And this is a symbol for infinity. All right, so when the object is placed at principal focus, number one, what can we say? Is this object going to be real? Yes, because you notice that if these two lines will meet at infinity, it means that they are going to meet outside the mirror. So it's going to be real. Is it going to be inverted? Yes, because you notice the two lines now is under the what? Under the principal axis. So when they meet at infinity, the image is going to be inverted because it's going to be formed under this line. So it's inverted. Now, what about the size? It's going to be magnified or still enlarged. Why? Because you notice if they will meet at infinity, no matter where they will meet, if I will draw the line up here, you notice that it's still going to be big. So it's magnified. Now, where is the image formed? The image is formed at infinity. So the image is formed at infinity. So take note of this, that when the object is beyond C, the image is between F and C. When the object is at C, the image is at C. When the object is between F and C, the image is formed beyond C. When the object is at F, the image is at the infinity. All right? So we are now going to be looking at the last case, our F and our C. The next is when the object is placed at a position between the principal focus and the mirror itself. It's just like when you move your face